Okay, so we are going to look at some exponent laws. Now we're going to break up this lesson into two parts. So the first thing we're going to do is we're going to take a look at these expressions. So on your notes, I've already typed everything out for you. We just have to fill in the blanks. Okay, so thank you, Mr. Chan, for giving you less work. All right, so let's take a look here. We have 3 to the power of 2 times 3 to the power of 2. Okay, and we're going to write this out in repeated multiplication form just to see how this works out. So we know that 3 to the power of 2 just means 3 times itself. And we want to multiply this by 3 to the power of 2, which is also 3 times itself. Now if you take a step back and look at this, this is just 3 times 3 times 3 times 3. So another way that we can write this is simply 3 to the power of 4. Okay? Let's take a look at the next one. 2 to the power of 3, so that's 2 times 2 times 2 again. Okay? Multiplied by 2 to the power of 4. 2 to the power of 4 is 2 times 2 times 2 times 2. So again, if we take a step back and look at this, this is just 2 times 2 times 2 times 2 times 2 times 2 times 2. There's 7 of them. So another way we can write this in exponential form is just 2 to the power of 7. Okay? And then this last little example here, 5 to the power of 4 is just 5 times itself, times itself, times itself again. So there's 5 to the power of 4. And we're going to multiply this by 5 to the power of 2. So 5 to the power of 2 is just 5 times itself. And here we have 1, 2, 3, 4, 5, 6. We have 6 of these 5s. So that's just 5 to the power of 6. Okay. So if you take a look at the exponents here, what's happening is 3 to the power of 2 and 3 to the power of 2, we ended up with 3 to the power of 4. And 2 to the power of 3 and 2 to the power of 4 turned into 2 to the power of 7. And then when we had 5 to the power of 4 with 5 to the power of 2, and we multiplied them, we end up with 5 to the power of 6. So hopefully you caught on that these exponents are just being added together. So when we write it as a single power, we just take the exponents from the other powers and just add them up. And that's our first exponent law here. So the exponent law says when multiplying powers with the same base, we can add the exponents to rewrite the product as a single power, which means if we have a, so this is some base to the power of m, some exponent, and this was being multiplied by a to the power of p, so like a different exponent. Okay. If we wanted to combine these, this would become a to the power of, and then we just add the exponents. So there you go. There's your first exponent law. Okay, so let's take a look at a couple examples here. Let's scroll down here. And, oops, I'll keep that up. So write as a single power. Okay, cool. We can do this. So 5 to the power of 3 times 5 to the power of 6. We're just going to add these exponents. So we have 5 to the power of 3, and then we're going to add that 6, which gives us 5 to the power of 9. Then let's take a look at this other one here. Okay, this one is negative 4 to the power of 5 times negative 4 to the power of 7. It has a base of negative 4, and our exponents are 5 and 7. So just because the base is negative doesn't change the fact that this exponent law still applies, right? We still have negative 4 as our base, that's no problem. And we're just going to add these exponents. So 5 and a 7. The base stays the same, and then 5 plus 7 gives us 12. Okay. So that's how we write these products as a single power by using this exponent law. Let's take a look at another type of example. So here, we want to write as a multiplication of two powers, then as a single power. Okay, so what they want us to do here is this stuff in brackets, we're going to write that out as a power first. Okay, so each of these brackets, we're going to write it out as a power. So 3 times 3 times 3, so this first set of brackets here, okay, this is just 3 to the power 3. Okay, and this is going to get multiplied by this next set of brackets. So 3 times 3 times 3 times 3 times 3, that's 3 to the power of 1, 2, 3, 4, 5, 3 to the power 5. Okay, so we got the first part done, right? Write as a multiplication of two powers. There we go. We got two powers being multiplied together. And then we have to write it as a single power. And now we know how to do that. We just use that exponent law that we just learned. So 3 to the power 3 times 3 to the power 5. Well, we just add the exponents. Okay, so 3 plus 5 is 8. There we go. Let's try B. 8 times 8. This is 8 squared. We're going to multiply this by 8 times 8. Okay, how many 8s do we have here? 1, 2, 3, 4, 5, 6 8s. So that's 8 to the power of 6. Now that we've had this laid out, okay, let's apply our exponent law. So 8 to the power of 2 times 8 to the power of 6 will be 8 to the power of, what's 2 plus 6? 8. Cool. And there we go. So that's our first exponent law. So these exponent laws are just shortcuts from taking these operations from one form into another form. So we're going to take a look at another exponent law, but in order to set us up with it, we're going to take a look again with an expression that we're going to write out as repeated multiplication, and then we'll take a look at what it is as a single power, or in exponential form. So here we have 4 to the power of 5 divided by 4 to the power of 3. And what we're going to do is we're going to write this out as repeated multiplication. So this 4 to the power of 5 is just 4 times itself, and there's going to be 5 of these 4s. So there you go. So that's on top, right? 4 to the power of 5. Underneath, we have 4 to the power of 3. So 4 to the power of 3. Now I'm going to line these up so that the 4s are directly above one another. And if we take a look at this, we have a bunch of 4s on top, a bunch of 4s on the bottom. And we know that we're taking the top number divided by the bottom number. So a lot of these 4s are actually going to end up canceling each other out. Right? Like 4 divided by 4 is 1. And 4 divided by 4 is 1. And this 4 divided by this 4 is 1. Okay, so these are going to cancel out. And what we're going to end up with is 4 times 4. Okay, and underneath is just 1. So that's basically just 4 times 4. Well, what's another way of writing 4 times 4? It's 4 to the power of 2. Let's take a look at another example. We have 7 to the power of 6. So up top, we're going to write 7 times 7 times 7 times 7, another one, another 7. Who put in so many 7s? Oh, I did. Oops. Okay, and then underneath, we're going to do 7 to the power of 2. So that's 7 times 7. Okay, and then we're going to take a look at how many of these cancel out. So this cancels out with that. This cancels out with that. And I'm going to end up with 7 times 7 times 7 times 7. So this is what's left over after removing the ones that have been canceled out. And this is over 1. So again, this might as well just be 7 times 7 times 7 times 7, right? Over 1 doesn't do anything. So what's another way of writing that? Well, that's a 7 to the power of 4. Okay? So let's take a look again at our exponents and see if we can find a shortcut. So here we had 4 to the power 5, 4 to the power 3, and we ended up with 4 to the power 2. Okay. Over here we had 7 to the power 6, 7 to the power 2, and we ended up with 7 to the power 5. Oh, sorry, 4. So you guys see what's happening here with the exponents? Yeah, they're being subtracted. So when we are dividing these powers, what we're actually able to do is simply subtract these exponents. So that brings us to our second exponent law. And it says that when we're dividing powers with the same base, we can subtract the exponents to rewrite it as a single power. So the word quotient here simply just means the result of division, right? So this power divided by this power, the answer will be called a quotient. And as a single power, we now have a shortcut for doing that. So if we had a power like a to the power of m, okay, so again, base of a, the exponent is m, and it was being divided by a to the power of p, okay, remember the base has to be the same. What we're going to end up with is a, so the same base, and then we just subtract our exponents. So it's going to be the top exponent minus the bottom exponent. So whatever that is, that's going to be our new exponent on our single power. There you go. That's exponent law number 2. So that's another shortcut we can use to simplify these expressions. So again, let's take a look at some examples. So let me scroll this up. We have write as a single power. Okay, so we have negative 2 to the power of 5. So we have brackets around the negative 2, which means that negative is part of the base. Okay, our base is negative 2. Our exponent is 5 on top and a 2 on the bottom. So what we're going to do here is our base does not change. It's still going to be negative 2. And if we apply the exponent law, right, we see that we're dividing powers of the same base. We just subtract these exponents. So my new exponent is going to be the result of 5 minus 2. And 5 minus 2 is 3. So this will ultimately turn into negative 2 to the power of 3. Let's do another one. This one here, 9 to the power of 12 divided by 9 to the power of 8. Okay, you can imagine how messy this would be if I had to write it out in repeated multiplication form. Can you imagine writing out 12 nines and then 8 nines and then canceling them all out? It'll take so long. But we can use this exponent law as a shortcut to make this a lot faster. So our base is going to be 9. And our exponent is going to be the result of the top exponent, which is 12, minus the bottom exponent, which is 8. So 12 minus 8 is 4. There you go. So that works out to 9 to the power of 4. And we're done. Here, let's take a look at another example here. This one says, write as a division of 2 powers. Then as a single power. So similar to the other example from the first exponent law, they want us to take the stuff in brackets and write that as a power first. Then we're going to go ahead and divide and get a single power as our final answer. So let's deal with what's up top. How many 5s do we have here? 1, 2, 3, 4, 5, 6. Okay, so we got 6 5s up top. So that's 5 to the power of 6. And underneath, we have 1, 2. 2 5s. That's 5 to the power of 2. Okay? So, again, we're going to use our exponent law, right? It's 2 powers being divided. They have the same base. And so my shortcut is that I just subtract the exponents. The top exponent minus the bottom exponent. So my base is going to be 5, okay? And then I'm going to take 6 minus 2, which is 4. And there you go. We're done. That's our second exponent law. So this is where we're going to stop for now. There are 3 more exponent laws, but we'll cover that next class. So this is what I want you guys to do. On page 106, we're going to do numbers 5 all the way up to 13. Okay? It seems like a lot, but if you take a look at our examples, we were able to do these really fast. Okay? So, use your notes, use exponent laws, try this out, and if you have any questions, ask Ms. Jen. Bye.